video is for anyone that was absent on the day that we did the fizzkeeper lab assignment. So we did do this in class, and we want everyone to have the same opportunities that those that were able to be in class had that day. Therefore, if you were gone on October 4th, 5th-ish, maybe before that, if it's a B day, you need to go to week 6. Everyone has the same week 6. And you need to go to the fizzkeeper lab assignment. You will be opening this document, and we will go through it together. Once your document is open, we read the background information, which says, chemistry is the study of matter. Matter is anything that has mass and takes up space. The air around us is considered matter, and it is made up of many different gases, such as oxygen, nitrogen, and argon. Air is around us all the time, which means it takes up the space around us. Air also has mass, but it's very small. You can think about that because if you just grab some air around you, can you weigh it? Can you feel it, how heavy it is? Probably not. So in this lab, we're going to try and prove that air has mass. So our overall question is, how does the number of pumps on a fizzkeeper affect the mass of a 2-liter bottle? Now, what I like to do first is I like to go through my question and I identify the variables. So if you remember going back to variables, our independent variable gets written first. It's also after the word how does and before the word affect. So I want you to take a second and look back at this question that we have right here and try and figure out what is in between how does and affect. So if you wrote down number of pumps on a fizzkeeper, you are correct. That is our independent variable. Next is our dependent variable, and that is what is being measured. And it also comes after the word affect. So what is being measured or comes after the word affect? Hopefully you figured out the mass of a 2-liter bottle. I think the hardest thing to think about is the controls. Now, the tips that I've told my students is that controls are the things that stay the same. You have to imagine yourself actually doing this experiment, which there is a video, and it can never be one of the independent or dependent variables. So if you already have variables written down in the independent category or the dependent category, those can never get written in the control variables. So if you read the directions or if you read the question again, there's going to be this contraption. It's called a fizzkeeper. We put it on top of a 2-liter bottle. It kind of works like how nowadays the automatic soda streams work, and how it puts the carbon dioxide and the oxygen into your water, and it makes it like soda water. That is what this fizzkeeper does if there was liquid in the bottle. Our bottle does not have liquid. Also, we will be having a 2-liter bottle, and think about how we measure mass or how you measure weight if you're at the doctor's office. These are probably some things that you'd want to keep the same. So I'll let you take a second and think about what I just said and try and write down 3 control variables, 3 things that we need to keep the same. If you said we should keep the same fizzkeeper, that is awesome. That is a first step. We want to keep the same 2-liter bottle. And then if you thought about how you weigh yourself or mass yourself at the doctor's office, you probably said scale. We use the term balances in science class, especially chemistry. So a balance is used. I write scale in parentheses because I know that's the term that most of my students are more familiar with. Next, we go on to our hypothesis. And remember, hypotheses are written in an if-then format. So if the, and which variable do we write first? Think about that. If you said that we write the independent variable first, you would be correct. So if the number of pumps on a fizzkeeper And I told my classes just pick increases because we can't take away pumps. Once it's already happened, it's happened. We can't go back and like suck out the air that already was there. So it can only go up from the beginning. So if the number of pumps on a fizzkeeper increases, then the what? What do we write after if? Or what's our second variable that we need? Now, if you said dependent variable, you're also correct. So then the mass of a 2-liter bottle, and this is where you can pick increases or decreases. I'm not going to tell you which one to pick. Please pick one. Please do not write both of those down. And you get to choose. It's your hypothesis. You won't get it wrong if you choose wrong. But just know that it is your choice. Oops. I just wanted to see if I could get it all on the same page, but I cannot. All right, then here's the procedure that Mr. Guyette is going to go through. So your job, you should pause this video. Your job is going to be to fill out this mass, this data table about the mass, and then you need to make a graph. So how you make a graph is on another video, but you need to make a new Google Sheet, and you copy this data table, you paste it in the Google Sheet, and you make a graph. I did not help my students with that, so I'm not going to help you guys with that. That is something that you guys should know how to do already. If you, like I said, if you need to get brushed up on that, go into our graphing section and you will get help there. So hopefully you paused and you got all that done. And now we're going to go into our CER. So our claim is always a one-sentence answer to the question that does not use the word because. So our question is written again. It says, how does the number of pumps on a fizzkeeper affect the mass of a 2-liter bottle? Remember, that was in the beginning. We already knew that question. And then our claim, which we wrote for you as an example, is as the number of pumps increases, the mass of the 2-liter bottle increases. So hopefully when you wrote down that data, you saw that the mass was going up. Now for evidence, we can write this in bullet point format, and I suggest having at least 4 bullet points to show a trend. Personally, as a scientist, I don't think 3 sets of data is enough because it doesn't end up showing the difference, or it could just be like you're selecting the data sets that make it look good, and you would really want to have more than 3 to show the trend. So what I do is I just pick like one in the beginning, one in the beginning, one at the end, and then 2 in between. So after 5 pumps, the mass was, and I want you to write out the mass. After 20 pumps, the mass was, and then your job is to go back into your data table here where you took the data and plug in some of these numbers. So I know it was like 76 something, but you have to fill that out. Now for our reasoning, there are 4 parts to reasoning. The first, I'll write the 4 parts first. First is to restate your claim. The second one is to add in evidence. The third is to tell me why this happened. And then the fourth is just to conclude or overall. Those are the steps. So when we write our reasoning here, I'll write it in blue again. I personally don't like to write the reasoning or the claim when it says restate the claim. Excuse me. I don't like to write it exactly the same as it is here. I like to kind of make it different and make it new. So I'm going to say it's going to mean the same thing, but I just use different words. So as the number of pumps increased, so did the mass of the 2-liter bottle. that's restating our claim. That was step 1. Next, we do need to add in evidence again, and you do need numbers. It needs to be quantitative data, quantitative evidence that proves what we're saying. Now, again, you don't need to write specifically all 4 of these, but you need to show me the trend. So you could say over 35 pumps of a Fizz keeper, the mass of the 2-liter bottle increased 0.30 grams. So I know that by taking the first data point and the last data point and subtracting the last data point from the first data point. But basically I subtracted the biggest number from the smallest number, and it comes out to be about 0.3 grams difference. So that gives you a number. It tells you that there was an increase, and it tells you by how much. Now we need to go into why. We're at number 3. Tell us why. Explain using science concepts. So this happened because think about what was going into that bottle. What made this mass go up? What were we trying to prove back from that beginning, back in the background section? We were trying to prove that air has mass. So when the air went into the bottle increased in mass, hopefully. So this happened because air was being pumped into the bottle, and air has mass. And then we just need to conclude. What I say is it's just like if you're writing an English essay and your very last sentence, it's just the one that wraps it up, ties it up in a nice little bow, and you just gotta wrap it all up and tell me you're done with it. So I usually use overall. You can use therefore, this is why, any of those kind of ending, concluding sentence starters. So I would say overall, as the pumps on a Fizz keeper increased, so did the mass of the bottle because air was going into the bottle and air has mass. So you're really just summing it up. Overall, what did you learn? What was the point?